Hey there, it's Joseph from Roboflow. Today, I'm going to show you how you can train your own YOLOv4 object detection model to any dataset to recognize any objects that you may have in your images and annotations. Now, for my example today, I'm going to be working with chess data. Before I tell you more about the data that I'm working on, let me show you that I have a working model so you know what we're working towards. Okay, so in my example here, I have this image, as you can see on the right in my Colab notebook. And I have all these pieces and they're not annotated. So let me go ahead and run inference on that exact same image file path in my notebook. Boom, just like that, you see in the output an annotated image and all of the labels are correct. There's the white king, the white pawn, black pawns, black bishop, etc. Now, for my example, my dataset is totally and freely available, and I'll show you where to find it. But let me first show you what's in our dataset. Okay, so inside my dataset here, I have a bunch of chess images. So it's just chess pieces on a chessboard in various different positions. I also happen to have my images already annotated with bounding boxes, defining where on the chessboard each of these pieces are. My bounding boxes happen to be made in VOC XML format, but chances are if you've already annotated in Coco JSON or CreateML JSON or even YOLO text files, you'll be able to follow along with today's tutorial. And if your images aren't yet annotated, you can either have us at Roboflow annotate them for you, or you can use an open source tool like ImageLabel to get things labeled for free. Okay, now let's dive in. The first thing that I want us to note is the tools we'll be using today are all completely free. That is, creating a free Roboflow account and using Google Colab, which provides free GPU compute. So the first thing that I need to do is get my data into Roboflow. And to do that, I just need to visit app.roboflow.ai. Now, I happen to already be logged in, so my account opens with the empty state here. You'll be directed to create your own account using your email or GitHub, whatever works best. I'm going to go up here and I'm going to create a data set. I'm going to call my data set chess example YOLO. It is a object detection problem. I have bounding boxes. And my annotation class is pieces. So I go ahead and create that data set. Now, as I mentioned, this data set is already annotated with my images and annotations all in this folder. So I can just take this folder and drop it directly into Roboflow. And at this point, Roboflow performs a series of automated checks matching my annotations against the images, and I get to visually inspect and see that everything looks okay. Some things that Roboflow is doing for me at this point is like, one, checking for 0 pixel bounding box annotations. For example, an annotation where I may have accidentally clicked or a labeler accidentally clicked on my behalf. It's also checking to see if any of my annotations exist outside of frame, that is outside of the image that I want it to be annotated. In that case, Roboflow trims the annotation so that it lines up exactly with the edge of the image. Now, I see that my images are all annotated, all 289 here, so I'm gonna go ahead and start the upload and create it to my own private Roboflow account. When I'm asked to upload, you'll notice that Roboflow asks me to create a train valid test split. This is best practice for when we're training and evaluating our models. I'll follow a 70-20-10 split just as Roboflow advises. Now, as these images upload, I want to note that if you want to get access to this dataset, you can visit public.roboflow.ai, where we have a series of object detection and classification datasets free to use. You can do things like detecting raccoons or working on thermal images. The dataset that I'm working on is here called chess pieces dataset. And if I open that up, you'll note that I could fork this dataset, which means add it to my Roboflow account, or I could work with one of the existing downloads. Now, I happen to already have this data downloaded and I just added it to my Roboflow account. But the process by which I added this data to my Roboflow account works for any data set. If you have a problem adding your images and your annotations, maybe they're not matching up, maybe there's some sort of problem, you can always reach out. Write us a note. We're happy to support new annotation formats. Okay, now that my data is in Roboflow, I can perform a series of checks, things like checking to see what my class balance is and seeing the size of my images, understanding how many objects I have annotated across each of these images. And that's what we call the dataset health check. And so Roboflow is performing these series of checks, and then it surfaces for me generally how my classes are distributed. You'll notice that predictably, because it's a chess problem, I have a lot more pawns than I do queens or kings, pieces that only appear once on a given chessboard. The other thing I'll note is that I have approximately 10 annotations per image, which means approximately 10 pieces were on the board. I have one null example, which means one board that doesn't have any pieces on it. And I have 0 missing annotations, meaning all of my images had a matching image file. I can also see down here things that like all my images are the same size, this size here, and the annotation heat map that shows me generally where my annotations are across each of my images. You'll notice that in the chessboard, my white king piece really didn't move around enough, maybe in my training data, and that could cause a problem for me. Same with my white queen piece. But alas, I'll continue on. The next thing I need to do in Roboflow is I need to create a generated version of my images. That means I need to go from my images in their raw form to a format that allows my model to learn from them. Things like resizing and removing auto-orient data from the EXIF data. If you're unfamiliar with that, you'll note that if you check out this step, we have this link here that says, when should I auto-orient my images? And you can click and visit that, and it walks through in greater detail on our blog why that matters. Now, I'm going to leave that turned on because I don't want my images to be improperly rotated in ways that I didn't anticipate when I captured them. The other thing that I'm going to do is I'm going to add a resize option. By default, Roboflow has this stretch to 416 by 416, but there's various different implementations of resize you might want to consider. I could do things like make sure that all my images are maintaining the same aspect ratio and then add black padding to the top and bottom. Or I could do a center crop where it zooms in to the dimensions of whatever I desire. For my example here, I'm going to go ahead and I will stretch to, and I'll do 500 by 500, or actually 416 by 416. The reason for that number is YOLO, the way that it performs its convolutions is it actually expects multiples of 32. And 416 is large enough where there's enough pixel clarity to understand, but small enough that my model can learn more quickly. Now the next thing is that I can add augmentation steps directly in Roboflow if I want. So things like rotating my images. Now this might make sense if I'm building a mobile application. Perhaps my images, the camera could come at the chessboard from various different angles. So it might make sense to do that depending on the context of your problem. For my case, I'll say that I will do, say, a little bit of random rotation up to 10 degrees in either direction. And you'll notice that I get an image preview here, and Roboflow shows me that my images could be randomly increased or decreased clockwise or counterclockwise by 10 degrees. There's a series of other augmentation steps that Roboflow allows me to provide, but for the sake of my example, I'm just going to do random rotation, and we'll say an increase and decrease of 25% brightness. Now, the last thing I'll note here is that Roboflow allows me to generate additional training data. So I could create 3 different versions for each of these chess images. That means that while my original dataset only had 289 images, each image will undergo the pre-processing step, so it'll be resized, and then at augmentation, it'll be randomly rotated from positive to negative 10 degrees, and then randomly made 10 or 25% brighter or 25% darker. So one image is going to undergo those 3 different random rotations. Maybe one time it gets rotated 8 degrees clockwise, the next time maybe 2 degrees counterclockwise, brighter, darker. You get the idea. So I'll go ahead and generate my export, and I can give it a name. So I'll just say, I don't know, I'll just call it 1 maybe, because I'm just going to call this version 1. And so Roboflow then creates and generates each of these individual images for me. While those images generate, I'm going to show you that the model that we're going to work on is available in the Roboflow model library. So if I go to models.roboflow.ai, I have a series of different models that I might want to use to train my data set on. Now, in my example, I said that we're going to be doing a YOLOv4 PyTorch today. So that's the model that I want to use. So I click in and I get a bit more information. Now, I'm going to be making use of Google Colab. So I click this Google Colab link, and I'm presented with, voila, a Jupyter notebook that has all of what I need to train a YOLOv4 model custom to my data. Now, the difference is that this Jupyter notebook is hosted on top of Google Colab, which means I'm able to use GPU compute for free. Now, there are some limitations of Colab, and I'll mention those in a moment. Now that I have this notebook from the Roboflow model library, I have to make a copy of it to my own account, to my own Google account, because this is Google Colab. So I'll go ahead and go up here, click File, save a copy to my own drive, and instead of calling this copy of, I'm going to call it, I don't know, JN Chess YOLOv4 Roboflow PyTorch, so that I know that this notebook is mine and my version. Okay, now let's go back to our Roboflow data. Our export has generated, and I am now confronted with the ability to create an export link or download the files directly to my computer. Now, for my example, I'm gonna ask for download code because I want to see the link that I use in my Jupyter notebook. The format that we need to use for our YOLOv4 PyTorch implementation is a .text format, and it's listed here as YOLOv4 PyTorch. So I select that format, and then I click Continue. And Roboflow creates a zipped file of all of those images ready for me to use and provides me with that link that I might need. Now, I quickly X'd out of that link here, and there's a reason for that. The reason is that link should be private to your own account. Do not share your Roboflow download link with anyone else. Now, I do want to note that I actually have the ability to download those locally if I want as well. And that means I could download and look at all my individual images. Recall that we generated 867 images from our original numbers, and I can actually see and look at these, and I see that some of them are randomly brighter, some of them are randomly darker, they were rotated a little bit, and this natural variation creates more examples for my model to learn from. And not only more examples to learn from, but in different contexts. Some of the rooms that my chessboard could be in production could be randomly brighter, or they could be darker, or the orientation could be a little bit different relative to the camera. So Roboflow simulates that with the augmentations that we selected. I also want to note that this version is frozen in time. So all of my settings here are archived so that I know which settings I used for each of my given exports. Now, let's return back to our Colab notebook. We'll note that you'll see a chess image when you open it up because this describes the everything we need. And from here, it's pretty smooth sailing. I mostly just need to run cells that call code from various places that I need. The first cell that I run does a clone of the Roboflow GitHub implementation, which is just this repo here, Roboflow AI, PyTorch, YOLOv4. And so we're bringing all of the contents of that repository directly into our Jupyter notebook, or our Google Colab notebook. And then I pip install all the requirements.txt required to run this given series of code and libraries. So, I mean, some of those requirements, for example, are things like a specific version of PyTorch, a specific version of NumPy, a specific version of scikit-image, specific pillow, et cetera, et cetera. And that will allow me to take advantage of the rest of my notebook here. While those install, I'm going to scroll ahead a little bit and show a few things. The next thing that we'll do is download the YOLOv4 weights that have already been converted to and ready to use for the format that we need. So this gdown command downloads from Google Drive on my behalf. So this cell will run right after the cell above it runs. And I want to note, if you're unfamiliar with Jupyter Notebooks, the way that you can run a cell is you can just put your mouse inside and then do Control-Enter, and it runs that cell. It's important that you run these cells in order for the purposes of having your data ready. Now, the next thing, now that everything is all set up inside our notebook, that means we have all the basics to run our code, we need to get our data. So we need to get our data from Roboflow. Now this provides a little bit of instruction of things that we already did. We already imported all of our data to Roboflow, and we applied a little bit of augmentation to increase our dataset size. The next thing that we can also do is unzip, is create that export from Roboflow, and then export the data from our Roboflow account to anywhere. In this case, we're going to export it to our Colab notebook. And you'll notice here that this is meant to be the export link we generated just a moment ago. So that export link was from our Roboflow account here. This export YOLOv4 PyTorch was the one that we want for this notebook. See, select YOLOv4 type PyTorch, show download code. And then I'm going to move this out of frame just so you can't see while I copy my link. And with this link, you should copy your link as well and drop it directly into your Jupyter notebook. So I'm going to move my Jupyter notebook out of frame for a moment while I drop my link in. And then I'll bring it back so you can see that I ran this cell. So I went ahead and ran that cell. Now, my link was here, but I replaced my link with the word done so as to not allow you to see it. But you'll see that all my files are now in my Colab notebook. If I click the file symbol over here on the left in the Jupyter notebook hosted on Colab, I can see train, valid, test. And those are the formats that came from Roboflow. If I open up any of those folders, like this train folder here, it populates with all these images and annotations. So this JPEG here is, there you go. It's that darkened black queen image, which looks great. The next thing that I do is I create a couple of directories. So I'm going to copy everything from train and put it directly into train.txt, copy everything from annotations and put it into train.txt. Do the same for validation as well. The next thing I'm going to do is I'm going to run a function that tells my notebook how many classes my problem has. And that's important because I need to pass the number of classes to the script that we're using for the purposes of training. And that's what this cell is. Okay, so this cell does a lot of things. It calls the train.py script from the code, this GitHub repo that we brought into our notebook. So it calls this script, and this script has a series of arguments, these flags that we pass. So let's talk a little bit about those flags. So B is the batch size. S is the number of subdivisions that we may want in the batch. -L is the learning rate. G is the direct to train on the GPU device, and that's already built in, so we can just say 0 because it's going to use the only compute available, which is GPU in Google Colab. And then I'm going to call out any of the pre-trained specific weights that I have, and in this case, I'm going to use the weights that I downloaded just a moment ago. I'm going to call out the number of classes, which num classes is this variable, so 12. And I'm going to call out a directory for where everything should be trained, the weights should be exported to. And then the last thing is passing the number of epochs that I want to train. Okay, so I run that, and this is where things will take a little while. Training isn't the fastest process, but this is free GPU compute from Google Colab. And so you'll see that the training process then begins to recite where it is, and it will train along the way. This is where I need to warn you that Google Colab, it is a free resource. However, it will not give you GPU forever. And it may not give you the best GPU available either. So some tests have shown that the GPU Google Colab gives you goes to sleep after 12 hours without any questions asked, and after 45 minutes if there's no activity in the notebook. In other words, if you have some important work saved, after 12 hours, it needs to be saved elsewhere. And if you just leave a browser tab running like this, and you don't check on it for about 45 minutes, or your computer goes to sleep or something like that, you'll lose training. You'll have to start over. So I recommend either using Roboflow Train, which is a service that we offer. We'll be able to train your models on your behalf and give you the ability to do this. Or you can upload or upgrade to Colab Pro, or you can set up your own GPU using all the requirements.txt. Now, as that finishes training, I have a little movie magic where I can fast forward and show you that this is actually already finished training. And so that's where I have my notebook over here, where everything indeed finished training. And here I'm going to tell you a little bit about what's being recorded. So every epoch, we're getting a few reports of how far along our model is. And we generally see loss going down over time. That's good. That means our model is learning our pieces better and better. And then at the very end, we can list out all those checkpoints. So all of those, we actually checkpointed every epoch, so there's 50 different checkpoints. In the notebook, we then actually grab a random image from the test directory. We pass that image to the model that you just trained using the weights that you just trained. And here, while we wait for inference, so here it actually found a series of all of these pieces. And then we can visualize that inference below. And look at that. We're right back to where we started at the beginning of the tutorial. Now, what's next? After you have your custom model trained, what should you do? Well, you might want to export your trained weights, meaning use your model somewhere else. You can export it to ONNX and use that to run. Actually, you can export it to ONNX to TensorFlow 2, or ONNX to run on device, whether that's a maybe GPU enabled Nano or something like this, depends on your context. Or maybe you're going to train and run it on a mobile application. Regardless, this allows you to export your model and go about your way. Okay, so we just walked through end to end how to upload data, prepare it, make it be ready, use the Roboflow model library to grab a model of our interest, and train our own custom YOLOv4 model to any data set of any interest. And you'll note that the performance is quite strong. Now, don't hesitate to reach out. Note that Roboflow is free to get started. So your first 1,000 images, which is plenty enough to train a successful model. And you can reach out to us if you have any questions along the way. help@roboflow.ai. We can't wait to see what you build on top of Roboflow. Thanks.